Hello everyone. In this lesson, we will work with finding the extreme points and the points of inflection. So, what is extreme points? So the definition for that is points having the horizontal tangent. For the tangent, okay, if the slope of that tangent is equal to 0, are called stationary points. Stationary points are maximum or relative maximum and minimum or relative minimums. So if we talk about maximum and minimum points, they have the general term called extreme points. So when we talk about extreme point, we will visualize that the points that we are working with, it will be either a maximum point or a minimum point. Okay? So I will go over the step of how to figure out maximum and minimum points, and then I will go to the definition of the point of inflection. So to find a maximum or a minimum point, what you need to do is you will be given a function to work with, then you find the first derivative of that function. Then you set the first derivative equal to 0. Why do you set the first derivative equal to 0? Because derivative of a function, that means you are finding the slope of the line tangent to the curve at that given point. So if you have the slope equal to 0, it means that you are going to talk about this tangent is a horizontal line, right? So let me draw the graph. Okay, so I have a graph of x and y axis. And on here I have a straight line. So this straight line is a horizontal line and it's parallel to the x-axis. So only the straight line here, the horizontal line here, will give you the slope equal to 0. So the slope of this line equal to 0. Okay, I'm not talking about a line, vertical line. Vertical line is a line perpendicular to this x-axis. That means you don't have any slope. Okay, vertical line, the lines that is parallel to the y-axis, it doesn't have a slope. So we have no slope, but the slope for the horizontal line is equal to 0. So if it is a tangent, okay, if it's a tangent line, then this slope is equal to 0. So what happened at this slope equal to 0? You either have a maximum point or a minimum point. Okay. So after you set the first derivative equal to 0, you solve for x. And after finding x, you are going to substitute that x into your original equation to solve for y. And how do you know that you have a maximum or a minimum point? You have to identify them, okay? Identify them by using the second derivative test. So using the second derivative test, if your y double prime is greater than 0, then the point is the minimum point. So you find second derivative, you substitute x into that equation, and if it's greater than 0, you have a minimum point. If the second derivative is less than 0, then you have a maximum point. If you find the second derivative, evaluate at the value of x and is equal to 0, then this test fails. And we have to, excuse me, use a different method. However, we are not going to mention about that method in this lesson. And when I give you a question to work with, I will make sure that this test will work. Alright? Okay. So what about the point of inflections? Okay, or they call inflection point, or the abbreviation for that is the PI. Okay, so the definition is right here. The points where the curve kind of change from concave upward to concave downward, or vice versa, is called the inflection point. So let me kind of clarify this to everyone. So I can quickly draw a graph. Okay, so I can draw. So if I have a graph that look like this, okay? So in this graph, if you notice that there's a part that I have the graph kind of concave down, okay? Concave downward here, and then this one concave upward. So in between here, somewhere here, there will be a point of inflection. That point of inflection tells me that this is the part where the curve or the function will change the concavity. So it will be changing from the concave downward to the concave upward. Okay, so in this case, I can find the point of inflection here somewhere. And I can tell you that in here, you will find this is the maximum point, and somewhere here is a minimum point. And if you draw a line tangent to this, do you see that? It's a straight line. If I draw a line tangent to this point, it is a horizontal line, right? Horizontal line, horizontal line. And the horizontal line slope equal to 0, slope equal to 0. The second derivative test will tell me which one is a max and which one is a min. And it's probably obvious that you see on the graph. However, we will need to work with the derivative test to identify or to prove that. Okay, so the next step is how do you find this inflection point in where on this graph right here? So what you do is you have to find the second derivative, right? And you set the second derivative equal to 0. Then you solve for x. You substitute x into the original equation to solve for y. And you have a point of inflection. So what I'm going to ask you to do is take a look at these two circles that I have for everyone. We are going to put some fun into mathematics, okay? So all of the rules that I put up here, like all of the rules to find maximum and minimum point, what kind of test you have to use and recognize which one is max, which one is min, is actually condensed into these two diagrams. So I will draw happy face and should I say grumpy face or angry face, or how about I say sad face? Okay, so I will draw a happy face here for everyone. Okay, so I happy face, okay, the eye, and a smiley face like that. Okay, so when you have a smiley face, it means that this is your concave up of the where the part is actually concave upward. Then if you draw a tangent right there at this point, right? So it means that the slope of this line is equal to 0. You are having a minimum point. So a minimum point, what is this positive mean? That means you are going to use a second derivative. So to remind you to use second derivative, I would draw the two pieces of hair on this face. So in this case, I would like to ask everyone to note that this is the second derivative test. Okay, so y double prime is greater than 0. Okay, so if you have the second derivative test greater than 0, it means it's positive. Then the point that you are finding here is a minimum point. So minimum points is when you have this curve, concave up, and then right at that you are having a tangent, and the tangent is equal to 0. Right? Okay. So then you probably can guess the next face, the sad face, will look like this. So, alright. Okay, she's not smiling at all. And here we have the two pieces of hair to show that we are going to use the second derivative test. Okay, so I will make a note here. Second derivative test. And if my y double prime is less than 0, so it means that it is negative, right? Okay, so the curve or your function will be concave down, and then right here is your maximum point. And at that maximum point, if you draw the slope, the line tangent to that, then you are having a slope equal to 0 because it's a horizontal line. Alright, okay, so I hope we put a little bit of fun into mathematics, and it's easy to remember this smiley face, and it's easy to remember this sad face, and then we don't have to memorize all of this rule that's setting above here for us. Alright, okay, so let's get on with our example. Alright, so I am asking everyone to take a look at this function, y equal to x to the exponent 3 minus 12x. And I would like everyone to determine the maximum point, the minimum point of the following function. So I only ask you to find the maximum and the minimum point in this case. Alright? Okay, so I sketched the graph for everyone. Okay, so I sketched the graph. So it's easy to take a look at this and see, okay, right here, I will have a maximum point, and right here, I have a minimum point. We have to have the actual value for that. The graph will help us, okay, will help us to find and also to visualize this as well. So first of all, according to the definition or the rules, I have to find the first derivative. So I have y prime will be equal to 3x squared minus 12, right? Okay, so everyone remembers how to differentiate now, so we can differentiate very quickly. So then, don't forget, at this certain point here, so let me click on here, so you see there, and there, if I draw a line tangent to this curve at this given point, it has to be a straight line. Okay, it's a straight line, and it is a horizontal line, and is parallel to the x-axis. So I'm going to set this equal to 0. Because your y prime is in fact your dy over dx. And it is the slope, so I let that slope equal to 0. At this point, I am going to solve for x. So now you see you have a quadratic equation. This is a pure quadratic. Okay, with a pure quadratic, you are going to have the solution equal to each other, but it's opposite. Okay, so in this case, I will move 12 over to this side. I will have this. So everyone knows the algebra now. So 4 equal to x squared. So what I meant is two solutions, and they are opposite solution, is because I will take square root of both sides. If I take square root of both sides and square root of this, I must have plus or negative of the square root of 4. So in this case, I have x equal to plus or minus 2. Alright, okay, so I have two solutions for x. It means that if I let x equal to 2, I substitute into this original equation here. I can solve for one value for y. If I let x equal to negative 2, I can substitute in here and I find another value for y. Okay, so we are going to work with that. So when x equal to 2, then y evaluate at 2 for x will be, so let me write the equation again. Y equal to x to the exponent 3 minus 12x. So in this case, I can go ahead and write this one as 2 raised to the exponent 3 minus 12 times 2. So I should have 8 minus 24. So I should have negative 16. Okay, so the point you may want to note for yourself here is 2 and negative 16. And we leave it aside for now, alright? Because we have to do a derivative test in order to prove that it is a, in this case, I would say it is a minimum point. So when x equal to minus 2, y of minus 2 equal to negative 2 raised to exponent 3 minus 12 times 2. Okay, so in this case I should have a negative 8, a negative 20, and here is negative 2. So negative 8 plus 24, so I should have positive 16. Okay, alright, so in here is when x equal to negative 2, y is equal to positive 16. Okay, so let's label this 2 point on the graph. So it's negative 2, then I have 16. When it's a 2, I have negative 16. Okay, so obviously this is your maximum point and this is your minimum point. But the whole thing, the whole point in here is you have to use the second derivative test to figure this out. Okay, to prove that this is either this point or maximum or minimum. Okay, so what I'm going to do is I am going to show you and also to prove to you that if we do the second derivative test, y is a negative will make it, this one will be a maximum, while the second derivative test is a positive will make this one becomes so it's let me take a look at my face again. So happy face, then it is a minimum. So if it's a positive, it's a minimum right here. If it's negative, it's a maximum. Right? Okay, good. So I just want to draw the face so I remind myself how it works. Okay, so here is the face. Positive, positive, smiley, negative, negative, grumpy. There. Okay, so we are going to base on this in order to figure out our positive and our negative. All right. Okay, so what we have here is I am going to label this point again. Right here, this point and this point. Okay, so here I have negative 2 and 16, and here I have 2 and negative 16. Okay, so what we are going to do is I am going to put y prime equal to 3x squared minus 12, because I need this in order to find my second derivative. So the second derivative for this is just 6x. And what you do is you are going to substitute the value of x as you are going to substitute the value of x equal to negative 2 in here. Okay, so if I put in x equal to negative 2, I should have 6 times negative 2 will be equal to negative 16, which is less than 0, right? Negative 12, I'm sorry, negative 12. So y double prime at negative 2 is less than 0, okay? And so let's say less than 0, draw that face, is negative, negative, that. So this is a what? A maximum point. So when x is equal to negative 2 right here, I have a max. So here is a maximum point. Alright. So proving that a maximum point. Because the second derivative test is showing me that it is negative. Now, so we go to the next point. Okay. So I should label here is for the point negative 2 and 16. Okay, now for the point of 2 and negative 16, so y double prime evaluate at 2 will be equal to 6 times 2, which is equal to positive 12, which is greater than 0. Okay, so y double prime evaluate at x equal to 2, this one is greater than 0. So it's greater than 0. What do I have? I have a positive, a happy face with the second derivative test. So the point is right here. So that means I have a minimum point. Okay, so this point here is a minimum point. So this one is a min, and this one is a max. Alright, okay. So here I should have a max. Okay, so I am going to prove this to everyone. Okay, I'm going to prove this to everyone by I'm asking everyone to take a look at the graph that I put here. If I sketch the graph of y double prime equal to 6x, so 6x is a linear equation and it's a straight line going through this. Okay, so let me zoom it down so we can see both graphs at the same time. So I would like everyone to take a look at this for me. First of all, I would like everyone to pay attention to this part of the graph. Okay, so from this point to this point, all the way down, so this should be a negative, right? So this is the negative part of this graph. Is that right? It's absolutely the negative part of this graph. Okay, so if it's a negative, so I am going to just draw negative, okay, and I'm going to have a maximum point in this case. So let's take a look at this maximum point and project the point down to this graph. You see, it's right there in our negative part of this graph. Okay, so if you go to this part of the graph, isn't that positive? Yeah, it is positive, right? So, and if you project this onto here, you see that you landed on the positive part. So the positive part here is positive, and then a smiley face, and second derivative, and this guy is a minimum point. Okay, so it's fun, right? And then we can put some fun into mathematics, and we can remember all the rules. So I hope I get everything in place for everyone, how to figure out the max and the minimum point. Alright, so I have another one to work with. Then I think I can, if I can put it into 8 minutes, because I have 8 minutes left, I think I can do that. Alright, okay, so let's work with this one in this video as well. Okay, so for this question, the first thing I am going to do is I'm going to figure out the y prime. Okay, so y prime of this will be equal to 3x squared plus 6x subtract 9. Alright, okay, so from this equation here, derivative of x exponent 3 will give me 3x squared. Derivative of 3x squared will give me 6x. Derivative of negative 9x will give me negative 9. Derivative of 5 is equal to 0. And the next step is to set this equal to 0. So 3x squared plus 6x subtract 9, set this equal to 0. And I'm going to solve for this quadratic equation. So what I'm going to do is I'm not going to use the quadratic formulas. I am going to use factoring, and I noticed that because I have a 0 on this side, I can divide every single term by 3. Okay, so this I simplified it to just x squared plus 2x minus 3 equal to 0. And at this point I can factor this. I factor this as you are finding two numbers, which is multiply will give you the negative 3, and the same two number adding will give you 2. So those two numbers should be positive 3 and negative 1. So positive 3 and negative 1. Okay, so we did this in previous math courses, so I I will quickly tell you what they are, but if you want to know the process and you forget, I hope you can go back and review. So in this case, I have x equal to -3, or I have x equal to +1. So those are the two values. So then you can put it into your original equation to figure out your corresponding value for y. So when x equal to -3, I should have y of -3 equal to -3 all of it to the exponent 3 plus 3 times -3 square, 9, -3 plus 5. Okay, so I should have -27 plus 27 plus 27 plus 5. So in this case, I should have this equal to 32. Okay, and when x equal to 1, y evaluate at 1 is equal to 1 cube plus 3 times 1 square minus 9 times 1 plus 5. So I should have 1 plus 3 minus 9 plus 5, and it happens to be 0. Okay, so therefore there's 2 points for this. So the point I have should be -3 and 32, and the point I have should be 1 and 0. Okay, so let's take a look at our graph. So that point right there and that point right there. So right on, you see, right on this graph, and we have to look for the maximum and the minimum point. We just look for it. I'm sorry, I was a bit distracted. I looked at my time. And one thing I want to remind everyone that doing math, you cannot rush yourself. Okay, so I realize that sometimes when I rush and keep looking at the time, I tend to say something I shouldn't be saying. Okay, so we have the 2 points here, but we need to prove that they are maximum or minimum. Okay, so what I am going to do is I will draw you to the next graph. Okay, and right here I can click that point for you, and I can click that point for you, and we know for sure this one is a max, this one is a min, but we still have to do a derivative test. Okay, so I think I do have enough time here. So to do a derivative test, I'm going to rewrite my y prime, which is my first derivative. Okay, so the y double prime will be 6x plus 6. Alright, okay, so at -3 and 32, I will substitute this -3 in here. Then I will have 6 times -3 plus 6. I should have -18 plus 6, so I should have -12, which is less than 0. So it's less than 0. What does that mean? Draw this face, a very sad one, second derivative. So this is my maximum point. So right here is the max. Okay, so right here is the max. Occurs at a -3 and 32. Okay, so obviously the other one is a minimum point, but we still have to apply our derivative test. Okay, so I will put at 1 and 0, then y double prime at 1 is equal to 6 times 1 plus times 1 plus 6. So in this case, I should have it equal to 12, which is greater than 0. So what is greater than 0 means? Greater than 0, I'm drawing this smiley face, happy smiley face, and there's my point right here. So it is a minimum point. So this one is a minimum, and the value is 1 and 0. Okay, and what about the point of inflections? So the point of inflection will be, okay, So let's put it in green. The pi, in this case, I will set my second derivative equal to 0. Okay, we set y double prime equal to 0. I don't think I have enough time, everyone. I'm going to stop